this is the final example for section 1.5. So far we've been talking about a lot of inverses, how to make an inverse, how to interpret inverses. This is what we call the algebraic inverse test. It tells us that if we're looking at two functions like we see here, how can we determine if in fact those are actually inverses of each other? Now, before we even do this, one way you could tell is if you put it in on the calculator and it looked like they were flipped over the line y equals x. That would just be kind of an informal way to determine that for yourself. But in this case, a little bit more straightforward approach is going to be with compositions. The algebraic inverse test says that if we do f of g of x and it turns out to just be x, and then we also go the other way around and it turns out to be x, then these two are inverses of each other on their domains. So we have two different ways that we have to prove this. Let's start with f of g of x. Like we talked about in compositions, f is going to be kind of like the outside skeleton to this, so this is going to be empty space cubed plus 1. That's my x cubed plus 1. And then I'm going to insert this one into the empty space. So cube root of x minus 1. Now I've got to prove, this is essentially a proof, it's not really that, you're just more verifying algebraically, but I've got to show that this turns into x. Now, one mistake that a number of people make when doing this, since it is kind of a proof or you're showing me, it's not a good idea to just cross everything out. We have to be careful about how we do this, so we start with what can be canceled in this problem. Well, the first thing, if we follow the order of the operations that can be canceled, is the cube and the cube root can cancel each other. If we do that, then what comes out is x minus 1 plus 1. Now we can see that, okay, minus 1 and plus 1, those cancel each other out. So that shows enough to prove that that's x coming out the other side. Now, if I just went here from the beginning and just said, okay, those 3's cancel, the 1 cancels, and I just cross everything out, well, anybody can do that. Anybody can just cross everything out and circle x. That's not going to be all that helpful in proving what we're trying to prove. The other direction is g of f of x. So let's make sure that one works as well. So our skeleton, our outer part here, is going to be the cube root. So cube root of empty space minus 1. And then on the inside, we'll put this x cubed plus 1. The order in which we cancel for this problem reverses, because now we're on the inside of this cube root. The only thing that can cancel immediately here is the 1 and the 1. Once we get that taken care of, then we can rewrite this problem now as the cube root of x cubed. It's really important to me that you show that transition, because that actually shows that you know what's happening in this problem, that you can show me an intermediate step, because now, of course, cube and a cube root cancel each other out and we get x. If you get it both of those directions, then we can say that we've shown the algebraic inverse test.